This is going to be an interesting one, and we have 2 to the x plus 4 to the x plus 8 to the x is equal to 39. We know our x belongs to real numbers, and we have to figure out the value of the x. So if we look at the left side of the equation, we have 2, 4, 8, which are basically 2 squared, and 2 cubed. So let's write it down like that. So we have 2 to the power of x plus 4 is 2 squared to the power of x plus 2 cubed to the power of x is equal to 39. And from the laws of the exponent, we know when we have a to the power of m to the power of n, this is equal to a to the n to the power of m. So basically, we can switch m, and the reason is that both of them are equal to a to the power of m times n. So that's why we can switch m and m. So let's do that on the left side. So we have 2 to the x plus 2 to the x to the power of 2 plus 2 to the x to the power of 3. So if we look at this, we'll see that we have 2 to the x to the power of 1, 2, 3, and if we look at the right side of the equation, or 39, 39 is actually a number that can be written as 3 plus 3 squared plus 3 cubed. So the reason we did that is if we in here just call the 2 to the x y, can simplify our equation to y plus y squared plus y cubed. And we have the same thing on the right side. We have 3 plus 3 squared plus 3 cubed. So now we can pair each of these two, and we're going to bring everything to the left. So all the positive signs will turn into negative. So we have y minus 3 plus y squared minus 3 squared plus y cubed minus 3 cubed. That would be equal to 0. Now we have difference of 2 squares and 2 cubes. So a squared minus b squared is going to give us a minus b times a plus b. And a cubed minus b cubed would be a minus b times a squared plus ab plus b squared. So let's do that. We have y minus 3 from the first one plus the second one. We have y minus 3 times y plus 3. And the last one, we have y minus 3 times y squared plus 3y plus 9. Now we can see the common factor in here. So we're going to factor y minus 3 in here. So from the first one, we have 1. From the second one, we have y plus 3. And from the last one, we have y squared plus 3y plus 9 equals 0. So now we have a times b equals 0, which means our a can be 0 and b can be 0 too. So y minus 3 is equal to 0, which means our y is 3. We called our y previously 2 to the x. So we need to solve this equation. We have our x in the exponent. We're going to go with the log on each side. So log of 3 is equal to log of 2 to the x. And the reason that we did the log on each side is that when we have log of a to the power of b, this b can go in the back. So it will be b times log of a. So now we can get rid of the x in the exponent. It will be x log of 2, and we're just gonna divide each side by log of 2, which means our x in here is log of 3 over log of 2. And also we know when we have log of a over log of b, this will be equal to log base b of a. So this is going to be log base 2 of 3. So that's one answer so far, but keep in mind that we did a is equal to 0 so far. So we need to do the same thing for b. If you look at b, you'll see that what we have in here is y squared plus 4y. So 3y plus 1y plus 9 plus 1, which is 10 plus 3 plus 13. So we have to have that one equal to 0 too. So y squared plus 4y plus 13 is equal to 0. So we can use our quadratic formula in order to find the answer for this, if there is any. So here our a is 1, our b is 4, and our c is 13. Now we're going to use our quadratic formula, minus b plus or minus the square root of b squared, or 16 minus 4 times a times c divided by 2. And if we look at this, we'll see that our discriminant is negative, which means there is no real numbers for this. And since we are looking for real numbers in this question, so we won't get any answer from here. So yeah, that's pretty much everything for this one. Hope you guys find it helpful. Let me know if you have another approach to solve this, and you guys take care. I'll see you in the next one.